All right, we're going to do 14, 15, and 33 in this video. So for 14, we want to find an algebraic expression for cosine of inverse cotangent of x. So notice how here, unlike the other problems here, we don't have a little fraction. So we're just going to make it as a fraction, right? So we have inverse cotangent of x over 1. That way, whenever we make our triangle here, I'm going to have x and then 1 right here. So x over y. This tells me that my hypotenuse is x squared plus 1 is equal to c squared, aka x squared plus 1 is equal to c. Now, because I want to find cosine of the inverse cotangent, which is this lovely triangle here, cosine of this right here, or cosine of theta, in this case, is going to be adjacent over hypotenuse. And honestly, you could just leave it like this and call it a day. Now, same thing for number 15 here. I want to solve inverse cosine of x is equal to inverse sine of 2x. So what I'm going to do here is go ahead and take the cosine of both sides. And then I'm going to make my little triangle, given that this is 1. So now I have my triangle, theta, right here. Since this is sine, this is going to be opposite over hypotenuse. So now I have a squared plus b squared is equal to c squared, where I have a squared plus 4x squared is equal to 1 squared. So a squared is equal to 1 minus 4x squared, which means that a is equal to 1 minus 4x squared. And then if I want to find cosine of this lovely triangle right here, cosine is adjacent over hypotenuse, so I'm just going to get 1 minus 4x squared. And that's going to be my right side. So this right here in green is going to be equivalent to this right here in green. But we still have this x in pink. So I'm going to set that equal to my green. Then I'm going to solve it. So I'm going to have x squared is equal to 1 minus 4x squared. 5x squared is equal to 1. X squared is equal to 1 over 5. X is equal to 1 over root 5, or root 5 over 5. This would be your answer for number 15. Now, same thing with number 33 in your textbook here. Except instead of a 2x and an x, we actually have root 2x and root x. But it's going to be the same thing. So I'm going to go ahead and cosine both sides. Now, if you want to sine both sides, that's okay, because honestly, it's going to give you the same answer anyways. But this is just my preference, having the x isolated already. Okay, we're going to make my little triangle. In this case, instead of 2x, I have square root of 2x, or sine. And this is 1, remember. So sine is going to be your opposite over hypotenuse. So thinking about your a squared plus b squared is equal to c squared, I'm going to have 2x plus b squared is equal to 1. B squared is equal to 1 minus 2x. And then if I take the radical, that's going to be 1, the square root of 1 minus 2x. And then to find the cosine of my triangle here, cosine is adjacent over hypotenuse. So I'm going to get 1 minus the square root of 1 minus 2x is equal to, well, this right here should actually be square root of x. It's equal to the square root of x. And of course, since they're just radicals, I am just going to go ahead and get rid of it. I'm going to solve it. That's how I get 1/3 x as my solution. All right, that being said, number 34 is another problem that is on your homework, which you need to do. So I'll be checking number 34 very carefully on your homework.